All right, welcome to The Explainer. Today we're going to take a guided tour of one of the most important, but maybe most overlooked parts of your body, the brainstem. It's kind of like the hidden control center, the unsung hero working 24/7 just to keep you alive.
I mean, really think about that for a second. When you're totally out of it, completely unconscious, something is still running the show. It's managing all those automatic processes that are absolutely vital for life. Well, the answer to that riddle is this remarkable little structure we're about to dive into.
So what exactly is it? On paper, the brainstem is the stalk-like bit that connects your big thinking brain, the cerebrum, down to the spinal cord. But honestly, calling it just a connection is a huge understatement. It is way more accurate to think of it as our silent, tireless life support system, just humming away in the background.
Okay, so let's get this tour started. We're going to make 3 main stops, and we'll travel from top to bottom exactly how the brainstem is built. We're going to kick things off with the midbrain, then move down to the pons, and we'll finish up at the absolutely critical medulla oblongata.
So our first stop is the midbrain. The best way to think about this part is as the body's reflex control tower. It handles so many of those super fast automatic responses that, protect us from getting hurt before we even have a chance to think about it.
Okay, so check this out. Inside the midbrain, you've got these 2 little pairs of bumps. The top 2, the superior colliculi, are all about visual stuff. That's why you instinctively duck when a ball comes flying at your head. The bottom pair, the inferior colliculi, they handle sound. They're the reason you instantly whip your head around when you hear a loud bang. It's literally your brain's built-in alarm system.
The midbrain is also where 2 super important cranial nerves, the ones that control your eyes, pop out. You can see them here, the oculomotor and the trochlear nerves. Pretty much all of your eye movements, from tracking your dog running across the yard to just looking up and down, are orchestrated right here. Every single glance, all coordinated from this one spot.
Now, buried deep inside the midbrain, there's the structure called the substantia nigra. Kind of cool. Its name literally means black substance, and it's basically the brain's main dopamine factory. And as you probably know, dopamine is this super important neurotransmitter that helps control our movement, our motivation, and our sense of reward.
And here is why this is so important. When those dopamine-making cells in the substantia nigra start to die off, it leads to the tremors, the stiffness, and all the movement problems we see in Parkinson's disease. It's just an incredible and kind of sobering example of how the health of one tiny cluster of cells can literally change a person's entire life.
All right, let's move on down to our second stop, the pons. The name pons is actually Latin for bridge, and that is the perfect description. This thing is the great connector.
So the pons acts as this massive relay station. It takes signals from the higher thinking parts of your brain, the forebrain, and zips them across to the cerebellum, which is command central for coordination and balance. That connection right there is what lets you do smooth, controlled things, like walking without stumbling or catching a set of keys someone throws to you.
And if you thought the midbrain was busy, whoa, the pons is an even bigger hub. It's the exit point for 4 different cranial nerves. These guys control everything from the feeling in your face to your expressions, eye movement, hearing, and balance. And notice how nerves 7 and 8 come out of this one little spot called the cerebellopontine angle. It is a very crowded and super important piece of real estate in your head.
And whenever you have a super crowded intersection, you're bound to get some traffic problems. One example is something called a vestibular schwannoma. It's a non-cancerous tumor that grows on the nerve for hearing and balance, that's cranial nerve 8, right in that busy little corner, the cerebellopontine angle.
This is a perfect illustration of why that location matters so much. As the tumor grows, it creates this really predictable pattern of problems. First, it messes with its home nerve, number 8, and you get things like ringing in the ears and vertigo. Then, as it gets bigger, it starts pushing on its next-door neighbor, nerve number 7, causing weakness on that same side of the face. And if it keeps growing, it can hit nerve number 5, leading to facial numbness. It's like a perfect clinical roadmap of the local anatomy. Okay, we've arrived at our final stop, and honestly, this is the big one, the medulla oblongata. If the midbrain is the reflex tower and the pons is the bridge, the medulla is without a doubt the survival center. Damage here, it's not just bad, it's catastrophic.
The medulla, man, it handles the absolute can't-live-without-them functions of life. It's got the control centers for your heart rate, your blood pressure, your breathing. It's also where the controls for swallowing and speaking live. And see that bit about the pyramids?
Those are huge bundles of motor nerves. And you know how a stroke on the left side of the brain affects the right side of the body, and vice versa? Well, this is the exact spot where that great crossover happens.
So it makes total sense that this survival center is the exit point for the last 4 cranial nerves. We're talking about the glossopharyngeal for swallowing, the incredibly important vagus nerve that wanders all through your body controlling your organs, the accessory nerve for turning your head, and the hypoglossal nerve which moves your tongue.
So, we've seen how this tour is supposed to go. We've seen how essential all these structures are. But what happens when the whole tour goes wrong? Let's take a quick look at what happens when the blood supply to this critical area gets cut off, causing a stroke.
Now this is where things get really fascinating, because it shows you just how precise the brain's wiring is. Depending on which tiny little artery in the medulla gets blocked, you get a completely different set of symptoms. If you block an artery supplying the side of the medulla, you get something called Wallenberg syndrome, with things like vertigo and trouble swallowing. But if the blockage is in an artery supplying the middle of the medulla, you see a totally different pattern. Paralysis on the opposite side of the body, and the tongue actually points towards the side of the damage. It is a wild reminder of how densely packed and organized this tiny area is.
And that brings our tour to a close. We've seen that this tiny stalk of tissue at the very base of our brain is controlling our survival, our consciousness, our most basic reflexes, all without any conscious thought from us at all. It's all on autopilot, which kind of leaves us with a big question to chew on. If all of that is automatic, what part of us is left to truly make us, well, us?